Alright, so today we want to look on alkanals or alcohols. Remember I tell you I like to call it alkanals to name it easier, but the functional group is alkanals or alcohols. So in the alcohol functional group, what we are seeing is an OH. So the functional group has an hydroxy group. So let's go. The functional group have an OH. Once you're seeing OH, hydroxy group, we're talking about alcohol or alkanol. Okay, so the first reaction we want to look on is the reaction with alcohols or alkanols with reactive metal. When alkanols are reacted with reactive metal, they form metal alkoxide and hydrogen gas. We get the alkoxide based on the number of carbon atoms in the alcohol, right? So in this scenario, we have ethanol that we are reacting with sodium. When ethanol reacts with sodium, this H is like an acidic H. So this H is going to be replaced by sodium metal. So this H in the alcohol from the hydroxy group behaves like an acidic H, replaces the sodium, and we will get C2H5O Na. Also, we get hydrogen gas forming, which is H2 gas. Because only one H come off and we form H2, to balance this reaction, we are going to put a 2 here, a 2 here, and also a 2 in front of the sodium. This is a liquid, this is a solid, this is aqueous, and that is hydrogen. So this name of this salt is going to be metal alkoxide, where it's going to be sodium alk 2 carbon S oxide. So it forms sodium ethoxide. Alright, so the next reaction that we want to look on is dehydration. So in dehydration, water should come to your mind. Dehydration means you lack water. So in dehydration reaction, we are losing water. When we lose water, we are losing water in the form of H and OH ion atoms. So we are removing water from the alkanol in the form of H and OH. In dehydration reaction, we start with an alkanol and we are converting an alkanol or alcohol to alkene and water. So remember, we are removing water. So in this scenario, we have ethanol here, C2H5OH. We are removing water. Remember, when we're removing water, we're removing OH and a H. So when we do that, we take off this OH and another H, we're left with C2H4, which is an alkene. So that's how we get that. So ethanol, under the condition of concentrated H2SO4, concentrated sulfuric acid, at a temperature of 70 degrees Celsius, will be converted to, remember we're taking off OH and H, will be converted to C2H4 plus H2O, water. So that's what happens. So we are moving from alkanol or alcohol to alkene and water. The condition for this reaction is concentrated sulfuric acid and 170 degrees Celsius. So remember, in dehydration, we're removing water, right? So if you have the structural formula and you're going to remove water, the first thing you're going to find is the carbon which has the hydroxy group, which in this case is this carbon right here. From the adjacent carbon now, you're going to remove the H. So we're going to take the H from this carbon. So the double bond is going to form between these two carbons. So let's go again. In dehydration, we're taking out H and OH. You take out OH from one carbon, OH, right? And we're going to take out the H from the adjacent carbon. Now, the carbon which is beside this, this one is this one, so we're going to take off that H. And when we take off that H, we have our double bond forming, so we'll be left with 1, 2, 3, C double bond. H there, a H here, one H up here, and three H's right there. Also remember that water is formed. So again, it's concentrated sulfuric acid, 170 degrees Celsius is the condition for this reaction. Review again, alkanol in the presence of concentrated sulfuric acid and 170 degrees Celsius is going to form alkene and water. Remember, in dehydration reaction, we're moving H and OH. We don't take them off the same bond, so we find the carbon with the hydroxy group and we're going to take it off from there. When we remove this hydroxy group, we need to take the H from the adjacent carbon, the carbon which is right beside it. So we're going to take away this H. Remember, an alkene is going to form. So where we're removing the water, the carbon double bond will form. So here, we remove these. You notice they're no longer there. What we have is a double bond. Right? So that's how we move from alkanol to alkene. So the next reaction we want to look on is oxidation. We are going to use an oxidizing agent such as potassium dichromate, acidified potassium dichromate to carry out this oxidation reaction. So in an oxidation reaction, an alcohol or an alkanol is converted to a carboxylic acid and water. Now, how do we come by this? Basically, this is how the functional group of an alkanol looks, and this is how the functional group of an alkanoic acid looks. C double bond OH, and the functional group for the alkanol is OH. So when we are converting, we notice that these H's have gone. These H's are no longer there. What we have replaced it with is a C double bond O. That is critical, right? So we are converting it to this functional group. In order to get the C double bond O, it means then that we remove these two H's and we add an oxygen to this carbon. Let's look at an example. So in this reaction, what we have happening is, so it's oxidation, what we have here is ethanol. Ethanol, the oxidizing agent, which is the acidified potassium dichromate, is going to add 2 oxygen. So we represent this, although this is the condition, this is what it adds to the reaction. 2 O's, right? You notice there's a square bracket between the O's, so it's not O2. It's called 2 free O's, so it's 2O, right? So again, these H's are going to be replaced. So I'm going to take out this and this, and I'm going to add the double bond O, right? So I'm having H. So I draw out what's here first, CH, H, because I did nothing to this carbon. And on this carbon, I replace the H and I'm going to add oxygen. So it's going to be C double bond O, and then this OH is still there. Now these H's are going to, that have left, will combine with the other oxygen to form water. So let's go again. Remember, the acidified potassium dichromate is adding 2 oxygen, right? This first oxygen is going to replace these 2 H's, right, and form the C double bond O. The next O is going to combine with these 2 H's to form the water. So in oxidation reaction, we are moving from a alkanol to an alkanoic acid by removing 2 H's and replace them with an O. So let's look here. In this scenario, we have CH. We have 2CH5OH, right? And we're reacting it with 2 free oxygen in the presence of K plus Cr2, K2Cr2O7. And when we do that, we are going to form this functional group. So to the first carbon, we have CH3, right? Because the next C goes on the functional group, COOH plus water. So we're moving from alkanol to alkanoic acid, right? So remember, ethanol to alkanoic acid. So acid general formula is CnH2n plus 1 COH. So remember, ethanoic acid has 2 carbons. So the first one is in the functional group. So this N is 1, right? So we have C1. 2 times 1 is 2 plus 1 CH3 COH. So that's how we get that. Remember we said the condition for the oxidation reaction is acidified potassium dichromate. Sometimes we can use acidified potassium permanganate because both of these are oxidizing agent. When we are using acidified potassium dichromate, we will observe, these are the observations that we will see. Acidified potassium permanganate is going to move from orange to green. This reaction is very important because this is the reaction that police uses in the breathalyzer test. So if there's a certain amount of alcohol on your breath or in your system, what's going to happen is you're going to blow over as potassium dichromate crystals. If the crystals turn from orange to green, it means that you would have exceeded the amount of alcohol to drink. So in the lab, when we're boiling the ethanol in potassium dichromate, it will move from orange to green. If we were using potassium permanganate, that would move from purple to colorless or pale pink. So these are the observations, and these observations are very important.